Alright, so the first example we're going to look at here is one involving fluid flow. In this case, we got a flow cell containing a cylindrical pipe with a well-defined radius. Allows, liquid to flow through it. You're told exactly how much mass of water leaves the pipe every second. You're provided with the density of water. And your goal is to figure out with what velocity does water leave the pipe. This can be done by examining the mass flow style equation. Now, the reason we're going to use the mass flow here is because we're actually told how much mass is leaving the pipe every second. Now, our goal here is to actually just find this velocity here. So the easiest way to deal with finding this velocity is simply to select parts of this equation, or two pairs of this equation, that deal with what we're given. And since we're told how much mass leaves per unit time, we're going to want this one and this one. So what that means is you can actually just cherry pick or select which parts of the equation that you want to use, and you can get rid of all the other ones, similar to what you did in Fick's or utilizing Fick's law. Now, when dealing with this, the mass flow per unit time, we actually know what that is. It's 200 grams per second, or 0.2 kilograms per second. And this is going to equal to our density, which is 1,000 kilograms per meters cubed, times our area times our velocity. Now here, we have one final step. We need to figure out what the cross-sectional area of this thing is. Now, the idea here is we have a cylindrical pipe. When you're dealing with a cylinder, the cross-section of it, so if you have a cylinder here, we'll draw one real quick. So this is my cylinder, and we'll do this properly for perspective. This is your cylinder. The cross-sectional area is a circle. So here, my area is going to be equal to pi times whatever the radius is squared. So I can find this area by taking pi and multiplying it by 0.2 meters squared. Again, converting 20 centimeters to meters. You can calculate what this is. Right, so just take pi times r squared, you get 0.126 meters squared. You can then put that in for the area, and you can solve for v. If you've done so, what you should get for the speed at which the thing leaves the pipe, or the velocity, is 1.59 meters per second. Right? And it's going to be in whatever direction the pipe is oriented in.